Hello, this is Douglas Rumbaugh. Today I'd like to talk about a utility that's provided in most Linux distributions called Logical Volume Manager. You'll see it called LVM, the acronym for it, quite frequently. And what LVM is it is a way to sort of abstract your hard disk. It allows you to, for example, link multiple hard drives together into one quote-unquote logical chunk of space, which you can then allocate into your what are known as logical volumes, which you can then mount directly onto your file system and use, for example, as your root or your home. And these can actually span the physical drives. It also allows you to very easily resize these logical volumes on the fly without having to go through all the heartache that's associated with trying to resize your file system when you're just using straight hard drive partitions to represent your different elements of your file system. In addition to all of this, it also means that if you, well, not in addition to, but as a result of those things, I should say, if you were to, say, install a second or third hard drive on your computer, you can very easily resize all of your partitions to take advantage of that space rather than having it sit out as its own little mount point somewhere that you can drag files into as you need it. You can actually extend your home directory from your first hard drive into the next hard drive you just plugged in fairly easily. So to demonstrate this, I have set up a system here. It's a virtual machine for Arch Linux. I have not installed anything. This is just the raw disk, or raw install right off the disk. And this particular virtual machine has two hard drives in it. So we're going to use LVM to essentially combine the two hard drives together. And I have created actually a diagram that demonstrates sort of what we're talking about here. So before I dive too deeply into playing around on the system, let's just talk at an academic level about what LVM is, what it does, how it works, and then we can actually apply that information on this Linux system. So here we have a hypothetical computer that has two hard drives in it and three partitions. The first hard drive has two partitions and the second one has a third partition. So say we wanted to put root on partition 1 and home in partition 2. But if we for example, ran out of space in partition 2 and we wanted to take advantage of partition 3, you really can't do that easily using just these raw partitions as your mount points. So if we had home mounted on 2, we can't very easily extend it into 3 to take advantage of this extra space. What more often than not will happen is you will have to mount partition 3 at some other mount point and then just take advantage of it and put files over there instead of in here, which is not ideal. Of course, it's better than not having this at all and having to delete files, but it's not really all that ideal. So what we can do is we use Logical Volume Manager. Now, Logical Volume Manager has three types of volume, if you will. It has physical volumes, which are the, as you would expect, the physical level. And then it has volume groups, which are comprised of physical volumes. And then it has logical volumes, which are divisions inside of your volume group. So if we scroll down, using LVM, we can define a volume group, which is comprised of physical volumes here. And each one of these physical volumes maps to one of these partitions here. So volume 1 is partition 1, volume 2 is partition 2, and volume 3 is partition 3. However, you can see it's all brought together in one unit, which allows us to allocate it using logical volumes as though it were one unit. So if we scroll down here, you can see here we have created these would be the logical volumes. And as you can see, they don't care about where the physical divisions on the disk are. You can span them across these physical volumes without a problem at all. You can think of the volume group as an abstraction of the hard disk. So it is essentially one hard disk partition that's made up of numerous actual partitions, but they're all treated as one contiguous unit of space. So in the example here, say we wanted to expand. Let's just go ahead and do this. And say you have a fairly standard setup here where we have our root here and our home here. And of course, you'd actually have swap and var and whatnot, depending upon how you set it up. But we'll just go with that. And each one is divided out. Now, when you run out of space on your disk, you install this second hard disk. See, this would be this partition 3 up here on your second hard drive. And ordinarily, what you would have to do is create another mount point and just expand it over like that. And you'd have essentially a third partition on your computer. But what LVM lets you do is you can simply take home and resize it to take advantage of all that extra space that you just put in there. Better yet, you can even take home and move it, resize it and move it, so you can take advantage of some of the new space, while then also expanding root to take advantage of some of the new space as well. So you can imagine how that would be very useful. So let's get started. The very first thing that we'll have to do to set up LVM, and again, this is just a raw hard disk right now, we haven't done anything with it, is we have to partition the disks. And I'm going to use gdisk for the GPT partitioning that I've historically used in these videos. So my first hard drive is at SDA. And to see where these are, all you have to do is list out the contents of /dev. And you can see we have SDA and SDB. Sometimes, if you're on an old system, they might be HDA, HDB. In this case, though, they are SDs. So we do gdisk on dev SDA. And we're going to create a new partition. Now, because this is a GPT scheme, and I'm ultimately going to use grub, we do still need our BIOS boot. Help if I did this right. 100 kilobytes. There we go, there we go. And I'm going to make it a BIOS boot partition. Okay. So that's standard. But now, rather than creating several partitions to represent our boot and our root and our home, all I'm going to do is create one new partition using the rest of the disk of type 8E00, which is Linux LVM. And we'll write that out. Because I have two hard disks, I'm now going to do the same thing. I'm going to fire up gdisk on SDB. And here, because we already have our BIOS boot on SDA, we don't have to bother with it here. And this can just be one big partition, again, of Linux LVM type 8E00. And we'll write that out. Okay. So, we need to create our physical volumes next. Called Lvm Disk Scan, which if you run it, it will present you with a list of all the devices on your computer that you can turn into a physical volume, as it were. And here are the two we're after. We have SDA2, which is our partition on our first hard drive, and SDB1. So let's do this. To create a physical volume, you want to use the pvcreate command, and then just type in the device. So we have SDA2. You'll see we created it successfully. And we have SDB1. And once again, we created that successfully. You can then use the pvdisplay command to show all the physical volumes that you currently have assigned. And you can see we have our SDA1 and SDB2. Now, if you should ever need to remove a physical volume, then that's just pvremove. Oops. And you can see we just wipe out the physical volume. Now, you cannot run pvremove once the physical volume is associated with a volume group. You have to start with the volume group and then remove the physical volume. I'll get to that when we actually get down to the physical volume level, or the volume group level. But until then, I'm just going to rebuild this particular physical volume. Okay. So next up is building out our volume group. And remember, the volume group is this. It's just essentially lets you take your physical volumes and link them together end to end to form one apparently contiguous block of space. Or at least the system sees it as contiguous. It's not physically contiguous. It's the beauty of abstraction. So all you have to do for that is use the volume group create command. This is vg create, and then you have to give it the name. So we'll call it vol group 00, and you can then list out your physical volumes. So we have /dev/sda2 and /dev/sdb1, and we created our volume group. Now, you can't use this vgcreate command to add a physical volume to an existing volume group. There's a different command for that, and I'm going to show it right now. So first, I'm going to use the vgremove command to get rid of the volume group we just made, like so. And I'm just going to create a volume group, again, this volume group 00, just using dev sda2. So say I just now installed my second hard drive and I want to add /dev/sdb1 to this volume group. To do that, we need to use the vgextend command. And again, we just give it the volume group name and /dev/sdb1. And just like that, we have extended volume group 00 into the physical volume sdb1. And if we use our vgdisplay command, you can see all the details pertinent to volume group 00. Of particular note down here are going to be the size of the volume group. And this, the PE stands for physical extent. This is the smallest possible unit that you can allocate. So we can't allocate a logical volume that's smaller than 4 megabytes. Is all that means. And here you also see the amount of space of the volume group that we have allocated and the amount that remains unallocated in both actual bytes and in physical extents. Okay, now that we have our volume group built out, we need to build our logical volumes. And these are going to represent the actual quote-unquote partitions on the computer. These are what we're going to mount on /mount and then on /mount/home and /mount/boot and what have you, and actually treat them as the partitions on the computer. So to do this, you guessed it, we need lv create. The individuals behind LVM were very kind and made all the commands consistent, which is not something that you see all the time on Linux. The next thing we have to do is give it the size. So you can use the capital L, capital L, and then give it a size. So we'll say we want a 1 gigabyte. We're going to allocate it out of vol group 00. And then we use attack and lowercase n to give it our name, and we'll call this root volume. So we'll have 1 gigabyte root volume. Next up, we'll do the same thing, except we are going to use, say, 200 megabytes to create our boot volume. We are going to use 300 megabytes and create a swap volume. And we are going to create our home volume. And we will allocate, say, 500 to that. Okay, so now if we go back and we use our volume group display command, you can see down here that we now have 1.98 gigabytes of space allocated and 1.02 gigabytes of space free. It's generally best practice when you're setting up LVM to leave some space at the end free, because that gives you room to expand if you need to. So if we were to, as I've done before, allocate not enough space to root, and then it fills up and you need to install another program, you have some space that you can just extend root into. short of course, installing a second hard drive. Okay, so now that we have our logical volumes created, we should be able to find them. If you go into /dev/mapper and list it out, you'll see here are our logical volumes. They're the name of the volume group, and then a dash, and then the logical volume name. So let's just start mounting up. We need to mount in here, so I don't need the full vol group 00 root volume on mount. No, we don't. The next thing we have to do, I'm getting ahead of myself here, is configure the file system. So this is done just like any partition, any physical partition. Use mkfs ext2/dev/mapper/vol group boot. Boom. And do the same thing for your others. And again, you can use your file systems of choice. There are many options here. And we want to use make swap for our swap. Okay, now we can mount it. And swap on our swap partition. Okay, so everything's all mounted up and good to go. The next step is just like any old Arch install. We want to use packstrap to install to mount our base system, and also we need to install LVM2. The LVM2 piece is important because it doesn't come in base. So if you don't install it now and then you Arch root in, you're going to have some problems. Now this is going to take a little while, so I will cut here and be back just as soon as it is done.